Welcome. So in this video, we're going to be going through question 5 of exercise 18F. Let's give it a read. It says, a car starts from rest and moves a distance s meters in t seconds where s is equal to 2 to the power of 4 plus 2 to the power of 4 plus 2 squared. What is the acceleration when t is equal to 0? So I need to find acceleration. What is acceleration? I know that acceleration can be found by differentiating the equation for my velocity. Acceleration is my change of velocity with respect to time. So before I can find acceleration, I need to find velocity. So to find velocity, what I do is I'm going to differentiate this, because this is giving me the position of where my car is. So I'm going to go ds dt, which is going to be 4t3 plus 2t. That's my velocity. I now, from this, can find my acceleration, because my acceleration is my velocity with respect to change, my change of velocity with respect to time. So acceleration will be dv dt, 12 2t squared plus 2. Now, what I want to do is find the acceleration when t is equal to 0. I know that when t is equal to 0, I'm at rest, because the question has told me at rest, from rest and moves a distance of s meters in t seconds. I also know that it's at rest because if I was to come here for a moment, and let's say I was to let t be equal to 0 for my velocity, it's quite clearly, I'm clearly going to get 0 out, because it's going to be 4 0 cubed plus 2 0. It's going to be 0, which means I'm at rest at that point. But just because you're at rest doesn't mean that your acceleration is 0, because you might begin to be moving, in which case your velocity would be increasing. So in that case, you have a positive acceleration. So let's come here now and let's go, all right, what happens when t is equal, I could even do this in the same way as I did here. What's going to happen when t is equal to 0? Well, I'm going to get 12 0 squared plus 2, which means I'm going to get 2 out. Now, the units that we use here are important. The units for velocity are centimeters a second. Actually, it's meters, my apologies. It's meters a second. For acceleration, the units that we use are meters a second squared. So you square that times the time that you're dealing with there. And what this is telling me is very important. What it's telling me is that I'm beginning to get faster, right? I'm beginning to get faster. Not by very much, but by a little bit. The question also wants me to find the acceleration when t is equal to 2. So I could take this, I could copy it with the power of technology. And now I could say, well, what happens when t is equal to 2? Well, that would be 12t squared plus 2 is equal to, now 2 squared is 4. 4 times 12 is 48. 48 plus 2 is 50. So it's going to be 50 meters a second squared. So what that means is my acceleration is even larger there. So if we can just picture this for a moment. So we've answered the question. The question is answered. There's our first answer. There's our second answer. Let's now just talk about what's actually happening here, and just giving ourselves a bit of a visual might be helpful. So let's come and let's draw for ourselves this object here. This object is about to move. It's going to move forward, and it's going to stop here. Let me come here. I might even copy it. So I'm at rest, right? My velocity is 0. And then what's going to happen is, you see here, I have 2 meters a second squared. That's my acceleration. So I'm changing my velocity slowly. It's slowly changing the velocity. But then after t equals 2, I'm changing it quickly because it's 50 meters squared. So I'm starting off slow. My change of velocity is slow, but then it gets quicker and quicker and quicker. So that's why my acceleration is increasing, because I started to speed up slowly, then I get faster and faster and faster. If, on the other hand, I had constant velocity, so let's say I moved like this. So as you see, I'm not moving, it's not increasing the velocity. The velocity is just remaining the same. So for this to happen, I would actually have to be moving initially as well, because, you know, otherwise you're starting from a point of stopping, then you're moving, so the velocity is changing. But let's just for a moment imagine that this is just at a constant velocity. So I'm moving from the beginning, I'm moving, the velocity is constant. That means my acceleration would be 0 because my acceleration isn't increasing. But what this is telling me is that I'm going from 2 meters a second squared to 50 meters a second squared. So my acceleration, I'm increasing my acceleration. So I'm starting off by increasing slowly, then I'm getting really quick, and then maybe I stop. I don't know, maybe I keep on going forever. Hopefully that makes a little bit of sense. In the lessons that I went through with you before you did your exercises, hopefully you got a really good intuition as to what acceleration is. It's that changing of that velocity. It's the fact that, you know, your velocity can change. You can become quicker. Your speed can increase. Orchidooks, I'll see you in the next video.